Lesson 41 is graphs of rational functions 3. So we have done graphs of rational functions twice before. The techniques are still there. We're adding on, you'll notice it says / repeated factors. That's the key we're adding on, is what happens to the graph when there's a repeated factor. So when there is an exponent on the factor, like on the parentheses. Okay? So, let's just jump straight into example 1. We're being asked to graph this equation, and, okay, wait a minute. I got white out in my notes here. What did I forget I need to change? Okay, take off that little 2 that is on top there of the x squared plus 2. Take off the outside 2 is what's supposed to be off. I forgot about that. Sorry. It's called a typo. Okay. So, y equals, first of all, did you guys notice what's out front? There's a negative. Okay, so don't overlook that little negative guy.
It's so hard to see because it literally just.
It does. I get it. Okay, so then it's going to be x squared plus 2, x minus 1 on top. Denominator is x plus 3, x minus 2, x minus 3, x plus 2. So I feel like this is mostly what you guys are already going to know, because we'll add in the repeated factors down below. So, what kind of details do we want to start with? Let's start with zeros. Zeros at where? I agree with the 1. Yeah. Okay, so how do we find our zeros? We set the numerator factors equal to 0, right? So the x minus 1 on top means there's going to be a 0 at x equals 1. If you solve x squared plus 2 and set that equal to 0, it becomes x squared equals negative 2. And so then x equals the square root, plus or minus the square root of negative 2. And so square root of a negative, we are now all of a sudden talking about imaginaries. Okay, we're only worrying about real zeros. So, the only physical 0 we're going to see is x equals 1. Let's talk vertical asymptotes. No tricks here. Okay, denominator equal to 0, right? So x equals negative 3, positive 2, positive 3, and negative 2. How do we decide horizontal asymptotes? Okay. If it was multiplied out, we'd look at the highest power, yes? Since it's not multiplied out, we kind of need to figure out what are the powers. So I hear on top there's x cubed, because there's x squared times x, which makes it x cubed. In the denominator, 1, 2, 3, 4. So x to the 4th. Tell me. There's a horizontal asymptote at y equals 0 because the larger power is in the denominator. This is all review, right? I'm just trying to jog memories and put it all together. The other thing I want to talk about, what does that negative out front mean? Okay, so that negative, because there's a negative out front, officially we're always supposed to begin at the right side of the graph. When we begin at the right side of the graph, we're going to be bottom side. Okay, so we're going to begin at the right on the negative side of the x-axis, and that's what I'm going to write here. Because we always begin at the right. The negative just says we start below. Okay, we ready to graph then? I like to do big long x-axis. Kind of need equal stuff on both sides, so y-axis in the middle. I'm going to go ahead and draw in my asymptotes. So let's see, we have vertical asymptotes at -3, -2, positive. We have a 0 at x equals 1. Officially, we have a horizontal asymptote at y equals 0 here, or in other words, the x-axis. What that horizontal asymptote is going to tell me is it's going to tell me what my graph is, where my graph is following along as it goes off to left and right. And the negative out front says that when I go to graph, I'm going to start bottom side over at the, that's what I got. So what's happening first? Yeah. We're going to curve and go down alongside that first asymptote at 3. What happens when you go over an asymptote? Okay, we ended negative, so now we're going to go up here, and we're going to be positive. What do we do between these two asymptotes? Okay, it's just going to be like a little parabola, because we have nothing telling us to cross through here, right? No zeros. So this is going to be some kind of parabola. What happens when we jump over the asymptote of 2? We ended positive here, so now we're going to start from the bottom. We cross through the 1. And then we have to make our way over to the asymptote at -2. Whoops. That turned out a little, not exactly what I wanted there, but it's the idea. Okay. Another asymptote to jump over, so we ended positive, so now we're going to start negative. This is going to be a little upside down parabola because there's nothing telling me to cross the axis. And another asymptote tells me to cross up to positive, and this one, right here, guys, why am I running off alongside the top side of the x-axis? There's a horizontal asymptote there, right? That horizontal asymptote is telling me in behavior. As I go off to, in that case, negative infinity, my graph runs alongside of it. Okay, the fact that this one maybe had no zeros, that might be on the newer side. We see it on occasion, but not as often. So, and that, notice that's because the x squared is in, it's x squared plus a number, and it's in the parentheses. So that makes it not factorable. Okay. Okay, repeated factors. And so what we're basically looking at is if any of these parentheses in the denominator up here had a squared on them, how would that change things up? Or if it had a cubed or a fourth power. Basically, if it had some kind of power. So as we look at this problem right here, let's look at example A. I'm pretty much going to go through all the same questions we just did on the top part. But this time we're doing part A here. So it's 4 over x minus 3 quantity squared. Notice there is a squared, and we'll talk about how that changes life. Any zeros? No, because there's no x in the numerator, right? Okay. So Just making a note to myself. Vertical asymptotes. If you take x minus 3 set equal to 0, that means it's going to be at x equals 3. Okay? Okay, so the squared. What that says is because there's an asymptote at x equals 3, normally what do we do when we get to about an asymptote? We change signs, right? If we were positive, now we're negative, or vice versa. The squared says you stay. So if you ended positive, then when you go over the asymptote, you'll still be positive. Or if you ended negative, you'll still be negative. Yep, and it'll be the same thing in that odd powers will still allow you to change signs. Even powers, make it repeat. And I think really I think you only see powers of 2. I don't think you see anything more than that. So I'm going to write a note right here. Powers of 2 says sign does not change around asymptotes. And so I'll demonstrate that, obviously. But there's a little note if you want to write yourself a note. Okay. Horizontal asymptotes. Y equals 0 because the bigger power is on bottom, right? When we talk powers, this one is 4 over. And where do we begin? Positive, yes? There is no negative sign out front. So this has a positive. So that says the graph begins. When we begin on the right, we begin above the x-axis. Okay? Or we'll hear it say small positive values. I'm going to write something in here. Graph begins with small okay. B, we're not going to write out all the information, so you don't have to have room to write out B, but you do have to have room to graph B. Just kind of FYI. Yep. That's why I said you don't have to have room to write out the information on B. But we are going to do we will do a graph on B. So, okay, so right now I am graphing A. No zeros. We had a vertical asymptote at 3. I should have moved my, oh well. We'll make it work. Let's see. No zeros, vertical asymptote at 3, horizontal asymptote. There along 0. Positive. Positive says we're beginning where? Right here on top. So what's going to happen at first? Okay, we run along the x-axis, and then we run along the vertical asymptote of 3. What happens when I jump over that asymptote? Okay, but because there was a power of 2 that says we stay positive, and so we're going to do that. We're going to go down. No zeros to cross, so you're going to go down and run alongside the x-axis. What's the only thing that's different about B? There's a negative. And so that's just going to tell me to start with negative, right? So x-axis, y-axis. Vertical asymptote again at 3. No zeros. Horizontal asymptote at 0. So what changes? Vertical asymptote of 3, I'm going to run alongside of it. What do I do after I jump over that vertical asymptote? Okay, it's squared again, so there's that even power, so we're going to stay on bottom and run along the x-axis. Here's another way to look at it. Did we just reflect our graph?
Yeah, okay, so I didn't really think of, or I guess I just didn't understand, but the squared means that when you go over the asymptote, you don't switch.
You don't switch, we're bouncing up and down. Yep, that's the big change. It's just you have to check what that power is. Okay. Ready to put this all together and try example 3? It's our last example for the day, I believe. Yeah. Well, this is a big example, so it's going to take me a moment. But okay. I'm going to go through my same questions, because in my mind, these are the questions you're asking yourselves. And I have to write them down because I need that visual. Zeros. Okay. There's a 0 at x equals 1. What about x squared plus 1? No, that will not be a 0. Now, because if I set x squared plus 1 equal to 0 and solve it, I'm going to get an imaginary. Because you'll get x squared equals negative 1, so x equals the square root of negative 1. Not happening. Yeah. Okay, now, what does this squared on this 0?
Not going to be this question. It's going to do something different because it's in the.
It's going to touch. It's going to make a little. I can't think what the word is. Opposite of a parabola. So be looking at it.
Well, it won't necessarily be V.
That's like a curve. It's going to touch it.
Okay. Okay, so remember zeros, if they're odd powers, they cross through. If they're even powers, they touch. So if it's all right up above, it'll touch and go back up. Or if it's so it won't cross through, it's going to touch. You guys know that. And I say you know that because it's in pre-cal right now. It's just a matter of remembering it. So do you remember multiplicity? Maybe, maybe not.
How many times is 0 occurs?
Yeah. So this has a multiplicity of 2, which means this is 0 occurs twice. Anytime it's an even multiplicity, it touches instead of crosses through. So I'm going to write a note right here. Even power touches.
Wait, is that just because it's in the numerator?
Because it's a 0, it's in the numerator. And when... Okay. Vertical asymptotes.
Negative 2. Positive 3. Multiplicity 2. Positive 6.
Okay. Vertical asymptotes. Negative 2, 3, and 6. Are we okay with that? That's denominators equal to 0, right? Now, what's the special case you have to pay attention to? 3 and 6 have even power, so there'll be no sign change. Again, I'm writing everything down. Even power at x equals 3 and 6. So, no sign change. Let's see, vertical, horizontal. What do we have in the way of powers here? How many x's are on top? 4 on top, and yeah, it should. In all honesty, this is a place where if you skip checking the horizontal asymptote, it's not going to affect you. Because the idea of rational functions is that there is a horizontal asymptote. And where is this graph going to begin? Positive. So, graph begins on right with small positive values. Just realized you guys haven't been able to see what I've been writing, but
Started it, no.
I hope you used pencil then.
I did, but I felt like I did it right at the same time I looked at it.
And there's a reason I write everything down. Because I like to have the visual. Let's see. What all am I putting on here? A 0 at x equals 1. Now, what do we know about that 0 at x equals 1? It's just a touch. My shortcut here is I like to put like a little T or C. You know, if we get into that where we're doing some of each, I put a little like T or C there to remind myself. I have vertical asymptotes at -2, 3, and 6. A horizontal asymptote is still technically at y equals 0, x-axis. And we are beginning on the positive side. Okay, so we begin on the positive side, no 0, so we're going to go up. What do you guys think? She says since it's 6, we stay up. 6 had an even power, and so that tells me we stay up. So I'm not changing signs. What am I going to do in between these two asymptotes? This is like a parabola. Now what? Okay. At 3, because it was a squared, we're not changing signs, so we stay up again. Okay. So this one, if it was a normal 0, we would cross through and end low. This is a touch. So that means we're going to touch and go back up. Yeah, I'm going to go with it's more lopsided. I don't know. Okay.
And now we can find the bottom.
And -2 did not have a repeated power. So now we do switch signs. So instead of, we ended positive, so now we're starting negative. And there we go.
I figured it. I was like, wait a minute.
I stayed up way too much was your feeder, wasn't it?
That is like everything basically up.
And again, this is where I like to, you know, I write everything out. It's all there. I think that's helpful. So,
Hey, Sergeant, do you have free calc next or algebra 2 next?
freak out.
Dang it.